Good day. You are welcome back to my class on complex analysis. Today, we want to learn something on application of DeMoivre's theorem. DeMoivre's theorem. And from the last lesson, you will recall that we say DeMoivre's theorem is given as cos theta plus I sin theta raised to pi n equals cos n theta plus I sin n theta for any natural number n, where theta and I have their usual meaning. So one of the applications, there are so many applications of DeMoivre's theorem in complex numbers, but I've listed 4 here. The first one is simplifying complex numbers. The second one, solving complex equations. The third one, finding the roots of unity. And the fourth one, proofs of trigonometrical identities. So in this class, or in this lesson, or in this lecture, we'll try to solve problems or look at 1 or 2 problems on the first 2, simplifying complex numbers and solving complex equations. So that is what we want to look at. So let's look at an example. This example here, that you should simplify minus 1 over 2 plus 1 over root of 3 divided by 2 raised to power 15. Everything raised to power 15. So that is what we want to do. So let's look at the solution. With this function, this number given to us, we can write it as z is equal to minus half plus I root 3 over 2. Then everything raised to power 15. So what we first of all do is to express what is inside here in polar form. So if you look at this one, half, this minus half is the value of x, and this one is the value of y when you are representing a complex number as x plus iy. So this one is the real part, and this one is the imaginary part. So the real part will be on x-axis, and the imaginary part will be on the y-axis. So if you now do that, we call this one Argand diagram. Argand diagram. So you have this as origin. In this z, your x is minus half, so let's mark it here. Let's locate it here. Then our y is root 3 over 2, so let's mark it here, root 3 over 2. So if you now trace this, and we also trace this one down, then it means that our z is here. So this is our z. So if you now join this one to the origin, we have this OZ, modulus of OZ to be the R, that is the radius. So this one is R. Now, in polar form, we have theta, and theta is the angle subtended by z with the positive direction of x-axis. So this one will be theta. But in this question, I want to have this angle as alpha. So this will assist me to find this angle easily. and this is an acute angle. Yes, this is an acute angle. So I'll find my alpha, then theta. After finding alpha, I will subtract alpha from 180 to get my theta. So let's go. R equals, from this triangle, using Pythagoras theorem, R squared will be half squared plus root 3 over 2 squared. So that is R. And this is 1 over 4 plus 3 over 4, which is equal to 1. Therefore, R will be square root of 1, which is 1. So that is that. Then, tan alpha degrees will be opposite over adjacent. The opposite is root 3 over 2 divided by half, and that is equal to root 3, which implies that alpha degrees is arctan of root 3, and arctan of root 3 is 60 degrees. So if you now take this one to pi, to radian measure, to angle in radian, it will now be 60 over 180 pi rad, and that will be 1 over 3 rad. So the result is 1 over 3 rad. Now, my required angle, that is theta. So theta will now be 180 degrees minus alpha degrees, which is 180 degrees minus 60 degrees, and that is equal to 120 degrees. So, and 120 degrees will now be 120 divided by 180 pi rad, and that is equal to 2 over 3 pi rad. Therefore, Z will be equal to, yes, what is our R? R is 1. So that will be 1, then into cos 2 over 3 pi plus I sin 2 over 3 pi. So that is your Z in that's Z star in polar form. But what we have here is Z raised to power 15. So Z raised to power 15 will now be equal to cos 2 over 3 pi plus I sin 2 over 3 pi, then everything raised to power 15. And invoking the theorem of DeMoivre, we have cos 2 over 3 times 15 pi plus I sin 2 over 3 times 15 pi. So you simplify, whatever the result. So these three will cancel here to give 5. These 3 will cancel here to give 5 here. So we have cos 10 pi plus I sin 10 pi. So that is the result. And by the time we want to look at what is cos 10 pi, know that cos 10 pi is 1 plus I sin 10 pi is 0. So, which implies that Z raised to power 15 is equal to 1. So this is the result. So let me give you a question here, like exercise. So for that exercise, I would say exercise. Show that minus root 6 plus I root 2 raised to power 8 equals 2 raised to power 11 minus 1 plus I root 3. I hope you'll be able to solve this and it will not be too difficult for you. So what you just do is to express what is inside here, minus root 6 plus I root 2 in polar form. Then you apply your DeMoivre's theorem, then you simplify. So you get this one. So that is an example on how to simplify complex numbers using the DeMoivre's theorem. So the next example that we want to solve is solving complex equations. Now, what we want to do here is solve for z in, let me use this, solve for z, the one that I've applied here. So solve for z in z raised to power 3 minus, no, yes, let me see. So z raised to power minus 3, raised to 3 plus half minus I root 3 equals 0. So want to solve for z here. You believe with me that this one is a polynomial of order 3 in z. So by the law of law of algebra, you have 3 solutions from here. 3 solutions. So z must have 3 solutions because this is a polynomial of order 3 and it must have 3 solutions. So how do we now go about it? Let's try to rearrange this. You have z raised to power 3 equals minus half plus I root 3. So what we first of all do is to express this one in polar form. So if you do that, we have done that one here. So the polar form of minus half plus I root 3 is cos 2 pi 2 over 3 pi plus I sine 2 over 3 pi. So that is the polar form of this. Now z will be equal to, is z raised to power 3. Let me quickly write this. So z raised to power 3, and if you want to have your z, then you raise this one to power 1 over 3. So from simplification, you have your z. Okay, z will be equal to this. So this will now be cos 2 over 3 pi plus I sine 2 over 3 pi. Then it will also be raised to power 1 over 3. But mind you, the period of cos and sine is 2k pi. So what we now do here is we rewrite what is inside here, this one, as z to be cos 2 over 3 pi plus 2k pi, okay, then plus I sine 2 over 3 pi plus 2k pi, okay, then everything raised to power 1 over 3. 1 over 3. For k equals 0, 1, 2. Now, let's simplify what is inside here. Now, 2 over 3 pi plus 2k pi so then divide by 3. That would be 2 pi plus 6k pi divided by 9. That would be the simplification. Okay, so you have that. So our z will now be equal to cos 2 pi plus 6k pi all divided by 9 plus I sin 2 pi plus 6k pi divided by 9 after we have applied the DeMoivre's theorem. You know what we're supposed to do is this 1 over 3, this 1 over 3 here will be used to divide what is here. So 1 over 3 to divide what is here. So if that is dividing, that's what I've simplified here. So this one is the simplification, and that one gives us this. So you have this, and that is for k equals 0, 1, 2. So to now get the roots, we now start to substitute our k in turn. So when k is equal to 0, we have z, the first z, possibly z0, will now be equal to cos 2 pi over 9 plus I sin 2 pi over 9. So that is k when k is equal to 0. When k is equal to 1, z1 will be, that's the second root. So that will now be cos, when it is 1, when k is 1, that will now be 6. So that will now be 8 pi over 9 plus I sin 8 pi over 9. And when k is equal to 3, when k is equal to 3, when k is equal to 2, when k is equal to 2, z2 will be equal to cos, that will be 2, so that will be 12. 12 plus 2, that is 14. So this will now be 14 pi over 9 plus I sin 14 pi over 9. So that is the roots. So the first root will be this one. So the first root will be this one, the second root will be this, and the third root will be this. So one thing about this root is that by the time you raise this to power 3, you are going to get this z. So any of the roots that you raise to, if you raise any of these roots, either z0, z1, z2, if you raise them to power 3, you are going to get back your z. So that is that. So I want to I can now give an example here that exercise using the same principle. Solve for z in z raised to power 3 equals minus root 6 plus I root 2. So you get the same thing. So that is that. Thank you. See you next time.